Have you ever wondered how you can pick up a glass of water or throw a ball with power? It seems simple, right? But behind these simple actions, a masterpiece of physical engineering is happening inside your body. You've surely noticed that when your muscles contract, they only shorten a little. So how can such a small contraction cause your entire arm to move a significant distance? Today, we're going to uncover this secret. Imagine you have a lever or a wrench. By applying a small force at one end of the lever, you can loosen a tight bolt with great force. Our body is full of these very levers. Every bone that moves is, in fact, a lever. Joints act like hinges, the fulcrum or pivot point, and muscles apply the force to move these levers. Now here's the key point. Our muscles are intentionally attached to bones close to the joints, the fulcrum or hinge. For example, your biceps muscle, that prominent muscle on the upper arm, attaches close to your elbow joint. When this muscle contracts and shortens a little, its attachment point on the bone only moves a small distance. Think of a seesaw. If you place a heavy weight close to the center, you'll need a lot of force to lift it. But if you place the weight far from the center, you can lift it with less force. Now back to your arm. Because the muscle is attached close to the joint, like the weight close to the center of the seesaw, even a small, short contraction from the muscle can cause the end of the bone, for example, your fingertips, to move and cover a large distance. In essence, your muscle exerts a very large force to create this large movement at the end of the lever, the bone. Here, our body has made a compromise, sacrificing direct muscle power in exchange for gaining more movement and speed at the end of the limb. You might ask, why exert so much effort? Couldn't the muscle attach somewhere else to make it easier? The answer is that this intelligent design gives us incredible speed and range of motion. Imagine if our muscles attached far from the joints. For activities like running, throwing, or even just quickly shaking your hand, we would need very large and long muscle contractions. Our bodies would become bulky and cumbersome because muscles would have to stretch across the farther parts of the bones. So with this clever lever design, our body can perform tasks like running, jumping, throwing, and thousands of precise movements with wide speed and range, using relatively small muscles and contractions that seem short. This demonstrates the unparalleled engineering of physics within our bodies. In summary, when our muscles contract just a little, they actually apply a great deal of force to our bones through a system of levers. These levers, bones,